This is problem number 9 for section 2.5. In this problem it says find the following limit. Is the function continuous at the point being approached? So again, if our limit as we approach this value equals the function defined at that same spot, then we have a continuous function. So when we go to find this limit, the first thing we always try to do is direct substitute. So if we directly substitute 0 into this equation, and we end up with a limit right away and not getting something that's undefined, then we're essentially proving that it's continuous because we're finding out that it's actually defined at that value of 0, and that is also the limit of the function. So that would mean the limit is equal to the defined spot for that function. So let's try that out. Let's plug 0 in, and when we do that we end up with limit as t approaches 0 of cosine pi over root 21 minus 5 cosine. We end up with 2 times 0 inside there, which will give you limit as t approaches 0 of cosine, this will now be pi over, we know cosine of 2 times 0, that's just cosine of 0, and cosine of 0 is 1, so we end up with root 21 minus 5, which equals cosine, or limit as t approaches 0 of cosine pi over 21 minus 5 is 16, the root of 16 is 4, and then we can say that cosine of pi over 4, we know that to be root 2 over 2, and so when we plug 0 into this, there's nothing to plug it into, so we just end up with root 2 over 2. So the limit as t approaches 0, and we'll just call this function f of x, equals root 2 over 2. And the function with an input of 0 equals root 2 over 2. Because these two things are equal, based on our definition, we can say the function is continuous at x equals 0.